All right, hi everybody. I am Professor Masoni, and this is the first topic in our course, which deals with systems of measurement. So before we get into some of the different types of measurements that you take in a chemistry course, let's talk a little bit about what is chemistry. Well, in a very general sense, chemistry is the study of composition, structure, properties, and reactions of matter. And even though you might not be aware of it, chemistry happens all around you every day. In the slide here, if you've ever taken an Alka-Seltzer tab and placed it in water, what happens is that that tab, when it's placed in water, that tab actually undergoes a chemical reaction in water. And that bubbling that you see that's taking place in the water, and you can see it in the picture in the slide here, is a result of carbon dioxide being generated in that process when the sort of N-acid tab, the Alka-Seltzer tab, is breaking down. So that's an example of essentially a chemical reaction, which of course would fall under the category of chemistry. So in the next chapter, we'll talk a little bit about atoms and elements, and essentially atoms and elements make up chemical substances, and essentially your chemical substances is also known as matter. So matter is another word for all substances that make up our world. And acid tablets are matter, water is matter, glass is matter, air is matter. We'll talk about water a little bit. Water is a chemical substance. What is water made up of? Well, you might be aware that water is made up of hydrogen and oxygen. Essentially, as we'll learn, for chemical substances and for matter, you can sort of break them down into simpler components. But once you get to what are known as elements, then you cannot break those things down any further. And that's really the differentiation between chemical substances, matter, and what we'll learn as elements, which of course are made up of atoms. Now, essentially, the field of chemistry is actually, from my perspective, divided into many branches. And I give you two here, I guess. Yeah, they don't say two, they just say divided into branches. The two most common are organic chemistry, which a lot of you might go on and take our chemistry 1120 or 1130 course. And organic chemistry is the study of substances that contain carbon. Essentially, general chemistry is the very broad aspects of chemistry. In a sense, sometimes general chemistry is also known as inorganic chemistry. Inorganic chemistry would be, essentially the study of substances that, do not contain carbon. There are some substances that actually do contain carbon that are in the field of inorganic chemistry as well. Sometimes inorganic chemistry also referred to as general chemistry. But general chemistry is really what we're sort of doing here, looking at a very broad overview of the world of. All right, so at this point, let's start to get into our discussion of units of measurement. And essentially, when you think about a measurement, there are essentially, and sorry, let me go back and get my writing utensil all set. All right, so when you talk about a measurement, there are always essentially two parts to every measurement. There's a number and there is a unit. And essentially, you need both of these parts for every single measurement, because essentially a number without a unit is meaningless. If I came into a laboratory and I saw the measurement of 10, what would that 10 represent? Would it represent 10 hot dogs? Would it represent 10 students? Would it represent 10 milliliters? I can go on and on and on and on about all the different possibilities that that number of 10 could represent. And because there are infinite number of possibilities of what that number 10 could mean, essentially it means that the measurement is meaningless. Now, scientists essentially use the metric system of measurement. In most instances, the metric system is really the most common system that is used for units of measurements. They also have adopted sort of a modification of the metric system known as the International Standard of Units. And essentially the international system of units, not standard of units, the International System of Units. Essentially, the International System of Units is an official system of measurement used throughout the world for units in length, volume, mass, temperature, and time. Now, from my perspective, I know that that's the official system, but really in most instances, scientists use the units for measurements that are associated with the metric system. Now, there's a lot of examples where the metric system and the SI system have the same unit for a particular, or as we should say, the standard unit for a particular type of measurement. But as we'll talk about a little bit as we go through this discussion, there are some examples where they differ in terms of the unit that is used for a measurement. So we'll go into that a little bit as well. Okay, so here's just an overview of some of the different types of measurements, what the standard unit is in the metric system versus the standard unit is in the SI system. I'm not going to really worry about time so much. It's pretty self-explanatory, time in the unit of the second. The ones we're going to really touch upon are length, volume, mass, and temperature. And really in a chemistry laboratory setting, volume, mass, and temperature are probably three of the more important ones.